Welcome. Over the next few minutes, we're going to go on a little journey together. We're going to unravel a really cool mystery. How do we get from just a simple question to a solid data-backed answer? It's all about that path from curiosity to a real conclusion. So let's dive right in.
Every great discovery, every big idea, it all starts with a question. I want you to think of this whole process like a detective story, right? You've got a mystery on your hands, and to solve it, you need clues, you need evidence. Well, at its very core, that's exactly what research is all about.
All right, so let's start where it all begins. Every single investigation, every research project, it kicks off with that little spark of curiosity, a question that just demands an answer. This is where our journey, our quest, really gets started.
Now, when you hear the word research, you might picture, dusty old books or super complex labs, but really, at its heart, it's just a structured, organized way of finding reliable answers. It's not a passive thing at all. It's a really active, systematic quest for the truth.
Okay, you've got your question. Now what? Well, the very first step in our investigation is to figure out who or what has the answers we're looking for. We've got to identify our sources of information.
Let's imagine we want to know the favorite kind of coffee for every single office worker in the entire country. That whole group, that's our population, which we call N. But here's the problem. Asking every single one of them, it's pretty much impossible. The group is just way too big. And that leads us to the much more practical solution, a sample, which we call a lowercase n. So instead of trying to ask everyone, we pick a specific, smaller, more manageable group. Now, the absolutely crucial part here is that this sample has to be a good representation of the bigger population. If it's not, our findings won't really mean much.
So, how do we actually pick this sample group? Well, with random sampling, everybody in the population has an equal shot of being selected. It's kind of like drawing names out of a giant hat. On the other hand, non-random sampling is more deliberate, more targeted. For example, you might specifically choose an equal number of workers from tech, finance, and healthcare to make sure all those groups are represented in your study.
All right, so we've got our question, and we've identified the group we're going to talk to. Now, what tools do we actually use to get the data? It's time to open up the researcher's toolkit.
And inside this toolkit, you'll find a few key instruments. You've got surveys, which can have closed, multiple-choice questions or more open-ended ones. Then there are interviews, which can be totally scripted or more like a free-flowing chat. But, choosing the right tool is so important. For example, if you send out surveys in the mail, you might only get a response rate of, say, 25%, and that can seriously skew your results.
And listen, before you go and launch a huge survey, there is one step you absolutely positively cannot skip: piloting. This is your test run, your dress rehearsal. You give your questionnaire to a small group first, just to see if the questions are clear, if they make sense, if there are any bugs you need to work out. Trust me, proper piloting pays off big time in the quality of the data you get. So, once we have the data, we need to know what kind of data it is. There are basically 4 levels or scales. Let's use marathon runners to explain it. First, you have nominal, which is just a label, like the number on their shirt. Next is ordinal, which is their rank: first place, second place, third place. Then you have interval, which measures the difference between things, like a performance rating out of 10. And finally, you have ratio, which has a true 0, like the actual time it took each runner to finish the race. Each level up gives us more powerful and detailed information.
Okay, the evidence is in. We've got piles of numbers, tons of answers. So the next phase of our journey is to start decoding it all. It's time to hunt for those hidden patterns.
So where do we even begin with all this raw data? Before you do any complex math, the very first step is always to just look at your data. A simple chart or a scatter plot can turn a confusing mess of numbers into a clear picture, revealing trends and relationships you would have never spotted otherwise.
Now, when we get into the more formal analysis, the tests usually fall into 2 main camps. Parametric tests are really powerful, but they're kind of strict. They come with assumptions, like your data needing to follow that nice, neat, bell-shaped curve. Non-parametric tests, on the other hand, are the flexible ones. They're distribution-free, which means you can use them on all sorts of data without having to follow those strict rules. And of course, we have specific tools for the job. A chi-square test, for instance, compares what you actually observed with what you expected to see. It's like comparing how many times you got heads when flipping a coin to the 50-50 split you'd expect. Or, if you wanted to compare the average results of 3 or more groups, you'd use something called ANOVA, which is way more accurate than just running a bunch of separate tests and risking more errors.
So, we've spotted some patterns, we've run some tests. Now it's time for the final and maybe the most important part, turning our analysis into a story that actually makes sense. What does it all mean? One of the best storytelling tools we have in data analysis is called regression. It's fantastic because it helps us understand and even predict how one thing is related to another. It often gets boiled down to this little formula, y equals a plus bx. Now I know it looks like scary algebra from high school, but trust me, the idea behind it is incredibly simple and really, really powerful.
Let's break it down with a simple story. Imagine y is your daily ice cream sales, and x is the temperature outside. The a is just your baseline, the sales you'd make even on a chilly day. But b is the magic number. It tells you exactly how much your sales go up for every single degree the temperature rises. See? All of a sudden, it's not some scary formula. It's a tool that helps you predict the future.
But, and this is a big but, we need a huge flashing warning sign here. This is maybe the single most important rule in all of data analysis. Correlation does not equal causation. Just because hot weather and ice cream sales go up together, that doesn't prove one causes the other. A correlation is a clue, a hint. It's not the final conclusion. Proving that one thing actually causes another requires a lot more evidence.
And that brings our journey to an end, all the way from a simple question to a compelling, data-driven story. I think the key thing to take away from all this is that data doesn't just speak for itself. It's just the raw material. It needs a curious person. It needs you to find the patterns, to give it a voice, and to shape it into a narrative that matters. So the only question left is, what stories will you help it tell?